Welcome to The Explainer, where we take really complex topics and break them down so they're super clear and, hopefully, pretty engaging. So, we're giving ourselves a little challenge today. Can you actually explain a super sophisticated malware technique and make it a viral 30-second video? Trust me, it's way harder than it sounds. To even try to pull that off, we've got to become the experts first, right? We need to be able to translate all that technical jargon into something that actually makes sense. So let's dive right in. We are exploring the very dark art of process hollowing. Okay, so what is process hollowing? At its heart, it's a master of disguise. It's this super sneaky technique that malware uses to hijack a trusted process, one that's already running on your computer. Think of it like turning a friend into a foe, but from the inside out. So what makes this so incredibly stealthy? I mean, come on, hackers have been injecting code for decades, right? So what's the big deal? Well, let's see how this technique builds on a classic method, but takes it to a whole new, terrifying level. Okay, check out this contrast. This is really where you see the genius of it. Classic DLL injection, that's kind of like sneaking a new passenger onto a bus. The bus is still the same, the driver's still there, you just have an extra person on board. But process hollowing? Whoa, that's totally different. That's like kicking the driver out, throwing all the original passengers off, and replacing the whole crew with a bunch of bad guys. The original program is literally gone from memory. You're just left with this hollowed-out puppet.
So how do they pull off this digital heist?
Well, the malware follows a very, very specific sequence of commands. It's like a precise recipe, and the crazy part is, it uses Windows' own tools against itself.
It's basically a 6-step operation. First, the malware starts a trusted program. Think your web browser. But boom, it freezes it instantly. Then, it just scoops out the program's original code. It carves out new space inside that now empty shell, writes in its own malicious instructions, rewires all the controls to point to its code, and then flicks the switch. Hits go. And this table? This shows you the exact tools they use. And what's wild is that these aren't some shady hacker tools. Nope, these are legitimate Windows functions. They're called APIs. Create process launches the target, but keeps it frozen. NtUnmapViewOfSection, that's the one that does the hollowing out. Write process memory is how they inject the poison. And then finally, resume thread wakes the imposter up. Every single one of these is like a lockpick, and they have to be used in the perfect order to pull off the takeover.
And the result of this whole elegant 6-step dance? Well, you're looking at one of the most effective evasion techniques in the entire malware playbook.
Okay, so this is the absolute crucial point. When you open up your task manager, you see svchost.exe running. Totally normal Windows process, right? You trust it. Your security software probably trusts it. But in reality, its guts, its memory, has been completely ripped out and replaced. It's a total wolf in sheep's clothing, and it's operating under a name that everyone has already decided is safe. All right, we've done the deep dive. We get it now. We're the experts. So, let's get back to our original challenge. How do we take that complex 6-step API sequence and turn it into something high energy, something unforgettable, and cram it into 30 seconds? Let's build it, piece by piece. Okay, step 1. You need an absolutely explosive hook and a killer analogy. Forget memory unmapping, that's boring. We're going with digital body snatcher. It's visual, it's a little creepy, and it grabs your attention right away. Next up, we map that analogy directly to the tech. Freezes it. That's our super simple, punchy way of explaining the create process call with the create suspended flag. See? No jargon, just immediate understanding.
And here it is, the core of the whole technique. Scoops its brains out. I mean, it's visceral, right? It's a little shocking, but it perfectly explains what NtUnmapViewOfSection does. It's memorable, and it just hammers home that idea of hollowing out the original code.
Now we have to visualize the payload getting in there. Pours in evil code is just a great visual metaphor for virtual Allocating and write process memory doing their thing, working together to fill that empty shell with the attacker's instructions. And finally, we hit play. That's resume thread. But the most important part of the message is that it looks totally normal, but secretly, it's a zombie. This gets right to the heart of why an attacker does this. It's all about stealth. And then you nail it, you end by naming the technique.
And of course, to wrap up any viral short, you gotta have a fast, super clear call to action. No hesitation. You keep that energy way up and tell the viewer exactly what they should do next.
So, what's the big takeaway here? Well, understanding these incredibly complex threats is obviously the first vital step. But being able to explain them clearly, to translate that language of APIs and memory sections into something everyone can get their head around. That's how we actually start to build a better, more collective defense. Because a threat that's understood is a threat that we can actually start to defeat.